where the lights are dim and the air carries that faint comforting scent of clean instruments and old paper. The hum is steady and low, like a distant fan, and somewhere nearby a microscope waits, its lenses neatly capped, its stage a small world of glass and gentle precision. We will drift together through patient, tiny mysteries, the ones paleontology untangles grain by grain, layer by layer, until a story that once seemed silent begins to whisper. If this calming journey helps you rest, please take a moment to like the video and subscribe, and feel free to tap the playlist link in the description so the learning continues softly in the background as you drift. What made you click? Title, thumbnail, or topic? Imagine yourself easing into a comfortable chair, your breathing slow, unhurried, and even. Somewhere in front of you, a thin slice of rock gleams softly under the microscope's light. It is the thickness of a hair or less, a sliver of the past turned into a window. The room feels timeless in that way laboratories can, outside the rush of day, inside a serene bubble of careful work. You adjust the focus with your fingertips. The motion is small and measured, and the view shifts into clarity. Tiny lattices come into view, arcs and lines, small bright grains locked in a pale matrix. They look simple at first, but as you linger, your eyes relax into the pattern, and the familiar gentle rhythm continues. Almost nothing moves, and yet a great deal is happening if you allow your attention to rest on the details. In the soft field of the microscope you see bone turn to stone, and even that phrase feels too sudden. Bone becoming stone is gradual and quiet. It begins with water trickling slowly through sediments, carrying dissolved minerals that settle into spaces where cells once lived. In life, bone holds an intimate architecture of tiny canals, of lacunae and delicate tunnels that fed and refreshed a living creature. After burial, the living parts fade, and mineral waters fill the spaces they leave behind, crystal by crystal, like calm snow settling into intricate grooves. The bone's microstructure, its little scaffold of life, resists the hurry of time. You find yourself admiring a set of circles and ellipses arranged almost like a garden pattern. Each circle is an osteon, and at the center of each is a canal that once housed small vessels. It is strange and soothing to realize how much of that arrangement endures among the minerals. The shapes are like quiet signatures, repeating without sound, each whispering that an animal grew here. Bone tells time in small strokes. Some animals leave rings, subtle lines of slowed growth and rest, like the tree rings you might have traced years ago in a cross-section of wood. In this little plate of fossil bone, the lines glow faintly under polarized light. When you rotate the stage, the colors shift from soft blues to gentle oranges. The effect is almost meditative, a watercolor of information. You can imagine a season long ago when food became scarce and growth paused, and a fine line settled into the tissue, a thin moment of rest captured forever. fossil is cleaned with a brush, tiny motions sending a bit of dust into the air that smells faintly of chalk. The fragment is embedded in clear resin that cradles it, the resin curing slowly, warm at first, then cool to the touch. A thin saw glides through the block with a whisper, its blade dressed with diamond grit. That whisper is steady, unhurried, like a lullaby of gentle friction. The slice moves to a glass slide, and the polishing begins. Water and fine grit working across the surface in long, slow strokes. It is a dance of patience, each pass thinning the slice until light can pour through. Later, a final polish draws out the subtlest details, sets the stage for colours that bloom under cross-polarized light, and the result settles on the microscope stage like a calm lake under a morning sky. You imagine turning the knobs again and gliding into another region. Now the bone gives way to a tooth, a fossil tooth pinned like a small dark star on a mount, its surface faintly glossy from years of pressure. Under the microscope, enamel reveals itself as an organized gem of tiny rods, neat bundles aligned and interlocked. In living enamel, this order resists wear. In a fossil, it still keeps its composure, even when the edges have softened. Along the biting surface, there are scratches. They are not deep or violent in this view. They are slender and orderly, trending in directions that reflect the little habits of chewing, the gentle path of one tooth gliding across another, or a sliver of grit smoothing a line as it passes. This microscopic pattern of wear is a map of meals long gone, recorded without hurry, and fixed here with a stillness that feels reassuring. Move to a different sample, a slice of a shell from a calm sea, and you notice layers like pages in a book. Some shells are built from thin plates stacked like shingles. Others hide tablets arranged in a mosaic, or fibers bundled in bands that run at angles like woven cloth. The forms are tidy and repetitive, a geometry almost musical in the way it repeats. Aragonite often grows in delicate needles or transparent tabs, while calcite prefers broader, more stable forms. Over time, aragonite can transform into calcite, a small rearrangement within a fossil, not unlike a slow sigh as the structure relaxes. In these layers, growth lines mark seasons of warmth and cool, times of abundant food and lean days when the ocean was quieter. If someone later studies the oxygen locked into those layers, they can recover temperature traces, a pale shadow of the water that once lapped softly around a living creature. To imagine that is to imagine gentle waves rolling over a muted reef and sunlight shifting with rippled patterns that slide across the sand. In another thin slice lies an eggshell. Under magnification, the shell is a maze of columns and pores, a house of channeled breath. Air moved through this structure, nurturing an embryo hidden from view and sound, and in the quiet chemistry of the shell's carbonate, the world outside touched a world inside. The columns rise with calm order, and the spaces between them form an even, gentle porosity that controls Some eggshells show a banded pattern that tells of laying and incubation conditions, each layer a soft step in a story of protection and patience. In some dinosaur eggs, crystals assemble into tall, orderly columns that break neatly at the surface, while in other clutches the structure is more interlocked and reticulated, like a net. It too can bear the small accents of time, mineral films that settled in, crystals that replaced crystals, and the structure still holds its design with quiet pride. You drift further, and the lab broadens. The bench holds boxes with labels that sound almost like lullabies when spoken together. Quartz, feldspar, apatite, calcite. Tools lie in tidy alignment, tweezers shining like small silver reeds, brushes clean and waiting for delicate duty. There is a calm in this arrangement, easy to take in with drowsy eyes. You imagine reaching for a pin to move a tiny flake on a slide. The flake is fossilized wood, and even at scales your unaided eyes can barely manage. Growth rings march outward with calm regularity. The cell walls, once cellulose, are now mineral ghosts, their geometry chosen by the tree long ago to lift water in rhythm with the seasons. Some pores are large and round for fast summer flow. Some pores are small, narrow, and frequent, a steady winter pace, careful and thrifty. The structure is meaningful and also simply beautiful, an order that seems to rest well with the mind. And then there are the smallest of the small, powdery smears that hold the bodies of planktonic travelers, little homes of calcium carbonate that once floated and sank through the ocean's gentle cycles. Foraminifera and coccolithopers, their shells and plates forming a soft rain that took millennia to settle into thick blankets of limy mud. Under high magnification, a coccolith looks like a round plate made of even tinier plates, overlapping in a carefully arranged rosette. Foraminifera often look like tiny shells with spiral chambers, some arranged in lines, others like onion layers in a spiral, each chamber a moment of life, adding to the architecture. In the quiet way of sediments, countless billions of these tiny structures accumulate, and with time and pressure become chalk, white cliffs that stand like silent pages for the wind to read, the sea nibbling gently at their base. In a lab, a pinch of such rock in a dish of water blooms in whiteness, and the microscope finds a cosmos of spinning plates drifting into view as the gentle rhythm continues. Even smaller, there are the silica skeletons of diatoms and radiolarians, whose walls look like snowflakes designed by careful hands. Their perforations resemble lace, and their symmetry calms the gaze. Diatoms You observe them motionless and balanced under the beam of the microscope, each pore and ridge clear, each reminding you that complexity can be peaceful. In another drawer is amber, the drops of ancient resin that caught small worlds and calmed them into permanence. Under magnification, you see flow lines where the resin moved and settled, capturing even the shape of its own journey. Within, there can be tiny plants, minute bubbles, fragments of air whispering of forests long ago. Sometimes you see a fibre, a fragment of feather, with microscopic structures called barbules extending from a central spine. Along those barbules, there are even tinier structures aligned like beads on a necklace, melanosomes that once held pigments. Their shape, whether slightly elongated like little sausages or more round like beads, correlates with the colour they carried, and people have used such quiet clues to infer sombre browns, subtle greys, perhaps soft iridescence, not with fanfare, but with patient comparison and careful statistics. In the warm honey of amber, everything seems to float, even the light, and your eyelids feel heavier as the gentle rhythm continues. Microstructures often record the little decisions life made to solve simple needs. Fish grow tiny crystals in their inner ears, otoliths that mark each day with a faint, pale line. Under certain light, the increments become apparent, around and around, like the rings of a tree, but finer and closer together. Counting those lines is the practice of timekeeping at the smallest scale, a careful tally that whispers of age and season, of migrations in water that cooled and warmed in slow cycles. In corals, layers lay down in bands that can be read to measure water temperature and chemistry. In shells, micro-growth increments record tides and lunar rhythms, the sea breathing in and out in patient half-day cycles that never rushed. You can imagine a reef at twilight, the water warm like tea against the skin, and corals building carbonate fibers grain by grain, their polyps opening and closing with a steady rhythm. The whole scene is steady, muted, and good for the heart. On another shelf sits a block of sediment waiting for palynology, the study of pollen and spores. The preparation might involve a series of gentle baths, acids and bases that dissolve unwanted material and leave behind tiny grains, each one a minuscule pot of plant identity. Under the microscope, they are delightful, with spikes, ridges, and patterns that belong to families of plants. Some look like stars, others like smooth spheres with precise pores. Each one says where and when the wind carried it, what kind of vegetation stood nearby, what the air felt like in terms of moisture and heat in a small region as time moved along. The lab smells momentarily tangy when these samples are processed, a sharpness that quickly gives way to neutral air once the containers are sealed. When the slides are viewed, the quiet returns, and the view is a field of tiny sculptures lightly resting on a glassy plane. In another space, a scanning electron microscope sits like a gentle giant, its column rising, its vacuum pump sighing in reassuring pulses. A shard of fossil is mounted with a small dot of carbon tape on a stub, and if necessary, a whisper-thin coating of gold or carbon is sputtered onto it, a faint metal fog to help the sample conduct charge. The machine peers with electrons rather than light, and as the beam scans, the image appears in shades of grey. With this approach, the edges of tiny crystals become crisp, and surfaces reveal their textures with clarity that surprises the eyes. You can see the tiny petals of a mineral blossom, the crisp fracture of a shell tablet, the faint tracks of bacteria etched into stone. With a detector that senses chemical signatures, the machine can even map the elements, colouring a view where calcium washes across an area and phosphorus dots a region like a quiet drizzle. In this space, time feels tall and slow, and each map is like a soft chart that the eye can explore at leisure. Sometimes the mysteries are even smaller, tucked into arrangements of atoms that imply temperature, or into stable isotope ratios that speak to climate. Imagine a coral skeleton in slices as thin as a whisper, its growth layers used to measure the oxygen in carbonate molecules. Warmer water tends to favour slightly different ratios than cooler water. A careful measurement gives a tiny number, and another tiny number comes from the next layer, and together they form a curve as calm as a tide chart. Clumped isotope measurements, which look at how heavy isotopes cluster within a mineral, deliver another whisper of temperature, independent of water chemistry, like having a second opinion told in a quiet voice. The methods involve delicate instruments that hum like content cats and measure things in small increments, repeated thousands of times. The end result feels almost poetic, a thermometer that endured eons locked inside a fossil's calm body. In the same gentle spirit, there are hints of life in minerals formed by living communities. Microbial mats can trap sediment and form stromatolites, layered structures that look like stacked pillows or rippled domes when cut and polished. Under magnification, the boundaries between layers are often wavy and uneven, a record of tiny organisms moving and modifying their environment in quiet teamwork. Sometimes minerals precipitate around organic structures and create tiny ovals or tubes, features that might record cells and filaments that once grew in films over stones. No alarm, no drama, just slow growth under a sun that rose and set like a pendulum. These records do not shout, they sit, patient, and reveal themselves to any eye willing to look long and listen to the faint rhythm they keep. There is also the matter of how fossils change after burial, a gentle process called diagenesis. In this slow metamorphosis, crystals dissolve and reprecipitate. Pores fill in, fractures heal with mineral veins, and sometimes gleaming minerals like pyrite form delicate spheres called framboids that look like tiny raspberries under the microscope. Their uniform size can hint at the chemistry of the pore waters, a murmur of conditions that were neither violent nor abrupt, just consistent over time. In bones, collagen vanishes, and appetite reorganizes in small increments. The overall shapes remain, and sometimes microstructures preserve exquisitely despite these quiet trades. genesis is to become familiar with patience and with the idea that even change comes in calm steps. Another door opens onto a small, careful ritual of magnetism. Some sediments retain a tiny alignment of magnetic particles, whispering the direction of Earth's field when they settled. Little grains of magnetite, sometimes single-domain crystals, so small they behave like reliably oriented needles, kept their bearing. In polished, thin sections, you might not see the magnetic moment, but you can see the grains themselves with their sharp outlines. In other instruments, with gentle fields, you can coax those grains to tell you which way was north when they fell from the water's calm surface. Pieces of basalt can carry similar messages. These microstructures then feed into a chronicle of geomagnetic reversals, helping date layers and tying local stories to a global clock. Even the planet's magnetic heart leaves a soft fingerprint on tiny minerals that waited quietly to be read. Now imagine the beam shifting to a conodont element, a tiny fossil tooth-like structure from an animal whose soft body rarely preserved. Under high magnification, a conodont element bristles with microcrystalline apatite, arranged in textures that tell of stress and strain, of sharpening and dulling, of gentle reheating deep underground that adds an even tint. Paleontologists sometimes use the color alteration index of conodonts to read the temperature history of rocks, a simple scale that is like a slow gradient from pale to deeper shades. The element itself might carry traces of wear along its tiny cutting edges. What looks like a grain of sand to the naked eye reveals under the electron beam a soar of life, precise and quiet. It is a reminder that the present is full of unseen details, and that sleep, too, is made of many small, quiet processes working together without announcement. Glass slides sit in racks, each with a label in neat handwriting that feels almost whispered onto the paper. There is a ritual to labeling that is as calming as anything else in the lab, a small nudge to order, a commitment to memory. The boxes are soft pastel colors. The pens produce lines that do not smudge. At the end of the day, the slides slip into cushioned sleeves, their edges protected, their information safe. In a digital file, images are archived with names that match the labels, creating a small architecture of knowledge that is easy to navigate. The routine here is restful. It has edges, but they are not sharp. It has rules, but they are not loud. The careful curation holds the space for long projects that stretch like slow rivers from season to season. Sometimes a sample returns to the saw to prepare a cathodoluminescence mount, to see trace impurities glowing softly in different colors when struck by an electron beam. The room darkens, and the sample lights up with oranges and blues. Areas that grew fast have one hue, areas that healed later have another. Cement that filled a crack long after deposition can appear as a new band of gentle light, distinct from the rest. It feels like watching a quiet city at night from far away, some streets still and steady, others brighter where repairs and additions once took place. When When the light returns to normal, your eyes adjust slowly, and the memory of those colors lingers like the after-image from a sunset. Back at the light microscope, pollen and spores drift across the field like confetti suspended in honey. Their walls often hold a polymer called sporopollenin that lasts beyond ordinary timescales, resisting weather and digestion. The consequence is a faithful record, a sampling of plant life that fell on a particular lake or bog as seasons strolled on. By counting the relative abundance of types, you get a picture of the landscape that is not abrupt but smooth, not theatrical but pastoral. It is the difference between a sudden clap and the soft chorus of crickets. To hold those counts in your hands as numbers is to watch a landscape fade and return, cool and warm, open and forested, all without haste. The instruments down the hall include a Raman spectrometer, which reads the vibrational fingerprints of minerals and molecules. The laser is gentle and neat, and the returns are line drawings on a screen. Peaks appear where certain bonds vibrate in the presence of light, lines that match patterns in a quiet library of spectra. A similar calm applies to Fourier transform infrared spectroscopy, which senses broad bands of absorption. In some fossils, faint original organics lurk within the mineral, and these methods, applied with patience and caution, hint that a whisper of past molecules remains. The audience for these whispers is small but attentive, and the methods require an even hand and a wait for the signal to emerge from the noise. The result is like hearing the faintest echo in a calm valley, present but unobtrusive. A tray holds shark dermal denticles, tiny tooth-like scales that cover skin and guide water flow in subtle ways. They look under magnification like rows of overlapping oars or small ridged shields. Their microstructure encourages water to slide past without forming large turbulent eddies, a modest but persistent advantage in the ocean. Fossil denticles can preserve those ridges and allow a quiet comparison across lineages and eras. The surfaces are matte or nacreous according to the type, but at these scales the most noticeable feature is how the ridges repeat, a soothing sight if one surrenders to its repetition. You imagine the slow pass of a hand over a smooth ridged surface, back and forth, and the mind quiets in sync. Somewhere along the counter, small calcareous shells of ostracods lie in vials. Under the microscope, their hinged carapaces open like seed pods, revealing delicate patterns on the inside, muscle scars like tiny hieroglyphs. The thickness of the shell and its chemistry provide clues to salinity and temperature. These microcrustaceans were abundant, and their record reads like a diary written in tiny folds. The quiet strength of a hinged shell suggests a life of opening and closing with the needs of feeding and defense, a motion as gentle as a slow breath. Plant cuticles also preserve at small scales. A leaf imprint can show the stomata, little mouths that regulate gas exchange, and the density of stomata correlates with atmospheric carbon dioxide. When conditions allow, fossil leaves hold silhouettes of these structures, analyses, the drilled powder reacting in a chamber that sings at a frequency too high to notice. The result becomes a number. Numbers line up in a spreadsheet, each one an understated note in a melody of climate or diet. Some numbers belong to carbon in carbonate, telling a story about dissolved inorganic carbon in waters. Some belong to phosphate in bioappetite, hinting at body temperature or food sources. Each measurement is like a footstep on a trail, whose destination is not rushed, whose slope is gentle, and whose turns are predictable. On a different bench, there is a little box labelled with the name of an ancient bird. Inside, a slice of feathered skin under the microscope reveals hints of the arrangement of follicle pits, a gentle spacing that correlates with feather density and pattern. In rare cases, pigment organelles, the melanosomes, remain, and with care, the distribution and shape suggest the cloak the animal wore. The colours that emerge are quiet ones in the reconstruction, earthy tones that suit the deep past in which they belonged. To imagine those tones is to picture a form moving through dappled light, blending with undergrowth, a tranquil presence in a long-vanished woodland. The mind shifts to the slow assembly of micro-CT data, where X-rays draw a stack of images that can be combined into a 3D portrait. The sample sits in a small chamber. The machine rotates it in tiny steps, and the detector records small differences in absorption. The software later rebuilds the volume, and you can navigate layer by layer, like sinking in a warm bath. You can examine the inside of a shell without touching it, trace a hidden canal in a bone, measure the porosity of an egg. The user interface is calm, grayscale gradients and sliders that slide as smoothly as a thought. It is satisfying to turn a sample in 3D, the model responding like a cloud that holds its shape while you view it from different sides. Even the glues and resins deserve a moment. Some smell faintly like pine when first mixed, and then the odour fades into nothing. They bind the samples to glass and hold them steady, and then they vanish from attention, a small scaffolding behind the scenes. The perfect bond is one you do not see or feel, like a night sky that holds every star without weight. The glass slides are clean and cool. Pressing a finger to a slide leaves a smudge that is easy to remove and satisfying to watch disappear. The cleanliness, the order, the soft shine becomes a landscape of calm. In taphonomy, the study of decay and preservation, there is a microcosm of interactions. A shell might be bored by tiny organisms that leave microscopic tubes, each boring a small hole that widens by fractions of a millimeter. Later, those holes can fill with sediment and form dotted patterns in cross-section. Teeth might carry micro-reactions where minerals replace dentine with darker calcite, or iron-rich ions drifted in like invisible visitors. The changes do not erase structure, they translate it into a new physical language. Reading that new language is like reading a poem's translation, savouring the original rhythm even through a new set of sounds. In Belemnites, fossil rostra from ancient cephalopods, growth bands stack like gentle ripples frozen in cross-section. The instruments' record seasons and migrations, sometimes showing narrower bands during lean times. A transverse cut reveals a rosette of splayed fibres with centre lines that comfort the eye with their symmetry. The path of a life that moved with tides and followed water masses quietly endures as a series of fine, repeating bands in a smooth stone that fits in the palm of a hand. The feeling of that smoothness, if you imagine it, is already calming. Brachiopod shells hold their own microstructures of spiraling fibers, punctuated layers of mineral and organic matrix, arranged in patterns that are tidy without being rigid. Light bounces through thin layers, and under cross-polarized light, the colors deepen, then fade as you rotate, a slow aurora in the small square of your vision. The movement is small, but compelling in a gentle way. No surge, no flicker, just a sliding gradient. An observer could watch this for a long time and feel content, the mind drifting on stable waves. There are records of ancient fires in microscopic charcoal, shards of blackened plant tissue with cellular patterns still visible. In a slide, these fragments look like small, crisp window panes arranged in irregular mosaics. Their presence in a layer speaks to a time when fires were part of the landscape, sometimes frequent, sometimes rare. The microstructure verifies that they are not soot or unburned wood, but something altered by heat. Even here, the observation is quiet. The pieces do not call out to be noticed. They simply present their structure and let inference take its calm course. When teeth from herbivores are examined, the micro-wear patterns change with diet. Leaves and grasses leave different traces than fruits and bark. Under tailored lighting, the scratches and pits appear across the enamel. Some are long and parallel, like multiple lines drawn with a soft pencil. Some are round and shallow, like small dimples pressed by a gentle finger. The pattern is not a single mark, but a collection of many that together suggest the texture of the food that passed through the mouth. The reading is statistical, careful, repetitive. The result feels like noticing the grain of a tabletop. It is there whether or not you choose to see it, and once noticed, it conveys more than the smoothness alone. Consider also the tiny layers deposited in lake beds each year. Varves, where a light band of summer silt pairs with a dark band of winter clay with organic material. Under magnification, the layering is crisp. A long strip from a core shows pairs repeating like tick marks on a ruler. One could count them and build a calendar, watching the intervals widen or thin in response to gentle changes in climate. This is time as a fabric, with familiar weave and occasional variations, an image that feels safe to hold in the mind. Now the scene in the lab shifts to a deep breath. You feel centered. You listen to the faint hum of the vacuum on the scanning electron microscope and the almost imperceptible whisper of air through vents, and you realize how much of science happens at this slow, careful pace. Another instrument, a microprobe, is ready to analyze chemical composition with tiny beams. The sample is mapped, and points are selected for analysis with the mouse leaving a dotted trail. The instrument fires its quiet page gently. There is satisfaction in columns, in the right edge of each number lining up, forming a steady border. In a corner, a core from the sea floor is laid out like a long loaf of layered memory. It came from a ship that maintained gentle station on a calm sea, while a piston and tube descended and lifted. The core was split lengthwise, and one half preserved and one half sampled. The surface shows colours in faint bands, some brown, some tan, some grey. Smears on slides reveal which microfossils dominate each interval. Changes in the abundance of warm-loving species can indicate a subtle rise in temperature. Changes in dust content show times when winds carried more particles from a dry continent to the ocean and then eased. The scale is large and the details tiny, and the marriage between them is graceful. In another tray lie microtectites, tiny glassy spheres that formed from molten sprays during impacts, and even at a small scale, their textures record fast cooling. Under the microscope, you see a smooth surface and sometimes faint bubbles, frozen as perfect circles inside. The glass is inert and patient, and the moment of melting has been calmed by time into a uniform bead. The bead rests against grains that formed in other ways, and the contrasts sharpen the senses without heightening the pulse. It is all part of the micro-story, and all of it is peaceful here. A small cylinder holds an eggshell pigment map produced by a gentle technique, showing how molecules like protoporphyrin and biliverdin are distributed across the shell. The pattern might reveal speckles and blotches that once camouflaged eggs in nests, soft patterns repeated with soothing regularity around the shell's curve. In some species, the pigments cluster in bands or flecked fields. In others, they are absent. Under careful examination, the pigments can survive in traces, and although the analysis requires sensitivity, the conclusions are tranquil. The nest, perhaps in a patch of dappled light, held a clutch that blended in, as if the landscape itself offered a lullaby of safety. The microstructures of sponge spicules, tiny silica needles and stars also hold interest. They can gather into layers that later form silicious ooze, hardening into rocks with a soft, crumbly touch. In the microscope, their perfect symmetry is impressive and soothing. Actinal rays meet at angles with mathematical grace. If you turn the light just so, the edges glow. The overall effect is like looking at a frost pattern on a window pane, intricate and quiet at once. Meanwhile, the lab notebook sits open with a ruled page, and you imagine your hand making a small sketch of a microstructure. The act of drawing a radial pattern or a grid of fibers slows thought to the pace of the pencil. The pencil's movement has a slight sound, a whisper, like a dry leaf brushed gently across fabric. The page gradually fills with shapes and labels, and even without colour, the drawing is a comfort, a sign that you watched and that the structure met your attention with steadiness. Later, in digital files, you add the photo that matches the sketch, and it feels like placing a pebble into a small bowl where each addition makes a soothing, muted sound. In the microstructures of plant wood preserved in coals and peats, there are vessels, fibers, sharp like metal. They are softened by mineral replacement, yet the lines remain legible. In the middle of it all, you pause to notice how your breath moves at a gentle pace, in and out, the chest rising and falling. The work does not demand a hurry, and sleep can approach like a wave that never crashes, just bears you up and sets you down again. How sleepy are you on a scale of 1 to 10? Instruments in another room harness beams from synchrotron light sources, producing maps of elements at micrometer resolution. Fluorescence of metals illuminates patterns of trace elements in shells, bones, and teeth. A ring of higher strontium might encircle a core, reflecting diet or water chemistry. The maps are gentle gradients, their contours like elevation lines on a quiet topographic map. You move your eyes slowly along those contours, appreciating how deeply layered information can be without ever feeling messy. Dental enamel, despite its hardness, sometimes retains its original crystalline orientation, and that alignment is visible under polarized light. Different mammals weave their enamel prisms in different ways, and those patterns are like woven textiles compared side by side. Some species favor decussation angles that cross in gentle zigzags, a fabric-like strength. Others display long parallel prisms, neat ranks and files. The view is orderly and pleasant. It is satisfying to see structure that solves a functional need while also giving the eyes a quiet place to rest. Think of a desert and the dust it sends across oceans. That dust lands on waters and drifts down, and in the microstructures of marine sediments, you can find mineral grains that are twins of those from continental rocks, shaped by their journey, edges softened. The presence of certain wind-blown minerals reveals dry conditions far away, a connection that hums under the headline of a climate state. In the lab, a grain from such a layer is placed under the microscope, and its facets bear the marks of weathering and travel. Turning it with a needle on the slide feels like moving a tiny planet, and the texture you see is patient and true. There is also the study of microborings, tunnels left by mollusks and sponges in carbonate shells. The networks are slender and branching, a minute labyrinth woven through a structure that once had a different purpose. Over time, these borings become filled and then lithified, and when the shell dissolves away, the filled borings stand like delicate tubes within the rock, a fragile city built after an earlier quiet one. The pattern reveals the presence of certain organisms in a particular time and place. If you trace the tubes, you feel the calm concentration that tracing requires, a flow of awareness just strong enough to keep you here, and just light enough to let sleep settle in the spaces around it. Soft tissues rarely survive, but sometimes the ultrastructure of cells leaves impressions. In the cartilage of fish, or the connective tissues of unusual fossil finds, there may be patterns that match biological regularity. Ion-milled sections reveal cleaner surfaces. The images show coarse reticulations, small vesicles, traces that are modest yet convincing. To acknowledge their presence is to allow a delicate idea into your hands and hold it without squeezing. In this lab, ideas are handled like the thinnest sediment or open nests with careful water exchange. Each pore channel is a slender, straight, or gently curved route from inside to outside. Measuring the density of those pores across a shell fragment gives a value that can be compared. The act of counting is comfortable. Clicks on a tally counter become a soft rhythm. The numbers build a picture as quietly as a watercolor fills with diluted pigment. In a drawer for reptiles, there are osteoderms, small bony plates that formed in the skin of crocodilians and other animals. Under the microscope, they show a mosaic of fiber bundles in organized layers, a fabric of bone that could flex with the skin and still resist pressure. The boundaries between layers are smooth and regular. The surface often shows pits that once housed soft tissues. In life, these structures delivered both protection and stability. In small, polished sections, they deliver texture and quiet pride. There are also the shells of brachiopods and bivalves that show differences in microstructure between interior and exterior layers. The interior may exhibit regular prismatic forms, while the outer nacre shows lustrous stacking of tablets. The break between these layers is not abrupt. It is a gentle transition, a shift in construction style. Such gradations are calming to see because they mirror the way changes often happen, less like a snap and more like a breath. In another study, researchers look at calcified cartilage in the jaws of sharks, the tessellated tiles of mineral that spread over a softer base. Each tile is polygonal and fits with neighbors like a low-relief mosaic. Together, they form a flexible but protective layer, a compromise made quietly by evolution's patient hand. When viewed in cross-section, each tessera has an internal fabric, and the boundaries are well defined but not harsh. It is beautiful in its understatement. The discussion of abrasion and transport in sediments echoes this theme. Grains polish one another gently as they move under currents, stillness interrupted by slow pulses. Under magnification, the edges of quartz begin to round. Microchipping occurs at sharp angles, and with time those chips are smoothed. A grain story of movement is written in tiny steps that accumulate. The presence of certain microfeatures implies that a grain tumbled for a time in the company of many others, not hurried but persistent, until it found a resting place in a delta or on a beach where waves wish and withdraw in an ancient rhythm. In a case with paleosols, ancient soils, thin sections reveal beds and voids, coatings of clay along pore walls, nodules of iron and manganese that form gentle speckling. Root traces wander. Their walls are lined with micrite, tiny carbonate grains that precipitated around the decaying root in arid conditions. This microstructure testifies to land surfaces that breathed. It speaks in layers and nodules and coatings. It is not a shout. It is a landscape whispering to you from the other side of time. Melanin granules in feathers, discussed before, also appear in fish skin impressions on rare occasions, arranged in patterns that hint at shading and patterning. Under the electron microscope, the shapes are consistent, and their distribution follows rules that fossils confirm such common sense in a way that feels balanced and satisfying. You can close your eyes and see a fish body with a gentle gradient slicing through calm water. In the world of conifers, fossil wood may carry resin canals, round openings once lined with secretory cells. These canals, in thin section, look like clean circles or ovals, often with a margin of darker cells. Their arrangement and abundance help identify groups, and the patterns are tidy and repetitious. They represent the plant's way of sealing wounds and deterring pests. In the fossil, they become serene records that fit nicely into the eye's desire for shape and balance. As the laboratory evening deepens, lights on display panels glow softly and cooling fans hum. A last set of images captures an enamel surface where perikymata, those fine growth lines, march toward the cusp. These are external expressions of internal growth rhythms in teeth. The concept that teeth grow in pulses and that those pulses leave small signatures on surfaces feels like listening to a heartbeat with a pillow over your ear, present and slightly muffled, and very reassuring. The camera shutter clicks with a gentle padded sound, and the file is saved. In the quiet of a storage room, cabinets hold drawers of slides like little libraries. Each drawer contains an arrangement of micro-worlds and gentle puzzles. The labels likely reflect not only the contents, but the thoughtfulness of those who prepared them, the steady hands and steady minds of people who return again and again to the bench and the lens, unhurried. In the hallway, a clock ticks softly, joined by the low rhythm of air returning from vents. You feel the kindly weight of time in this place, supportive and soft. If you imagine stepping outside for a moment, the night air greets you cool and still. The sky is clear and full of stars, each one a quiet point, far away and patient. You breathe in and out, and the lab's gentle activities continue behind you, even if no one is present. In your mind, thin sections still lie on the stage of a motionless microscope, not needing to hurry or change. The work will be there tomorrow, exactly as it should be, a promise of continuity that makes the shoulders relax. Back inside, one last look at a stromatolite slice shows gentle domes overlapping. The laminae are sub-millimeter thick, and sometimes the layers fan out where growth increase slightly. The record is ancient, but the scene feels fresh, a new sunrise each layer, microorganisms responding to light in a way that is timeless. You realize that small regularities like these exist at every scale, from the timing of your breath to the cadence of day and night, to the patterning of minerals in bone and shell. Each regularity is a quiet comfort. Each reminds you that the world has ways of settling into order, even as it constantly shifts. You recall the microstructures of an insect wing membrane, preserved in fine detail, where the veins left a faint imprint and the membranes themselves are translated into mineral films. The pattern of cross veins forms a net that looks both delicate and durable, with cells that vary subtly in shape. In life, such a pattern managed airflow and flexion, keeping the wing from fluttering irregularly. In stone, the same pattern holds, a frozen harmony that the eye can follow without strain. Your gaze can move along cementum growth layers around the root of a tooth may also be visible in polished thin sections. They accumulate slowly, thin bands wrapped around the root like a tree's rings wrapped around its heart. Counting them with careful cross-checks tells an age at death, a phrase that would sound heavy if one insisted on drama. But in this frame, it is just a measure of time lived, a plain count made with a gentle, respectful touch. The bands are so fine that reading them well feels like reading a whisper written on old parchment. At the boundary between life and mineral, biomineralization leaves guiding templates. Shells often accrete on frameworks of organic matrix, proteins aligned like threads. In fossils, the proteins might be gone, but the alignment they inspired can survive, marked by the orientation of crystals. The memory of organic order resides in mineral arrangement. This is a sweet idea to carry, that even when materials change, the forms of cooperation and instruction linger as shapes and textures. It is an idea that suits sleep because it treats change as continuity in slower clothes. Sometimes a cellulose wall in fossil plant tissue is replaced by silica from volcanic ash, opal A, then opal CT, then chalcedony, a gentle progression. The wedge-shaped crystals meet in ways that you can read with a polarizing microscope, and as you rotate the stage, the light dims and brightens. The sample dances slightly, an understated waltz, and you can step with it without moving, feeling the lull. Elsewhere, in calcareous nanofossils, coccoliths overlap and form aggregates. The degree of dissolution leaves edges and rounding that are measured by eye and by software. This dissolution index becomes a proxy for water chemistry in a calm ocean far away in time and space. The continuity of cause and effect comforts the mind. Small causes leave small effects, which, when counted patiently, teach us about large states of the world. It is a kindness embedded in the structure of nature, one that welcomes careful attention and rewards it with understanding that grows like dawn. Light. The lab's fridge holds small vials of standards, solutions whose composition is known to many decimal places. They are stable, unreactive, and clear. Using them makes the results trustworthy. The pipette's soft click, the feel of a droplet forming, the way it falls into a vial and dissolves with a tiny ripple. All of this is strangely calming. The ripple is over quickly, but in the mind's eye, it continues like a thought that has not finished its gentle travel. On the computer, an image of a dinosaur bone shows the Haversian system with remodeled osteons, some cutting across older ones at modest angles. Secondary osteons, with cement lines, form crescents and circles, each a repair, each a local maintenance of structure. Bone is not static, not even in life. It remodels in response to stress. Stress here, not as a shout, but as a daily conversation between tissue and load. In fossils, the remodeling reads as a life lived in motion, crossing a landscape, carrying weight trace the outlines, your finger above the monitor rather than on it, moving slowly. In another image, the vein of calcite in a shell crosses with a vein of silica, and where they meet, small subtle textures reveal which came first. Overgrowths with certain crystallographic orientations appear continuous or broken. It is a small puzzle, like arranging stones in a garden path, and the solution does not need to be announced. Locally informed, the conclusion settles into place like a pebble nested among others. The presence of microbial borings in mineral grains, small tubes etched by chemotrophic bacteria, tells of chemical gradients and slow metabolism. The tubes meander, but not aimlessly. They branch and thicken according to simple rules that feel almost like the rules guiding plant roots in soil. You see that nature reuses good ideas at many scales. If someone mapped these paths in colour, the view would be as restful as a contour map for a long walk across gentle hills. Amber again offers a special kind of microstructure. Air bubbles sometimes hold two phases, a liquid core with a gas bubble, the bubble moving slightly if the amber warms in your hand. The boundary between phases appears as a clean line in transmitted light, and the bubble's roundness is free of hard edges. In the same piece, a flow band arcs gently, and near it, sparkling micro-inclusions catch the light. The whole piece sits on black velvet for photography, and in that context, it glows like a small ember in twilight. It is very easy to let your mind rest on such an image. In dusty drawers, there might be microfossils called conularids, with subtle ridges that open like folded fans, their microstructure consistent across many samples, or tiny graptolite fragments with ordered rows of thecae, cups that once held colonial zooids. The details are minute and precise, and the survival of such precision after millions of years is a comfort, a sign that the world tends toward preserving some pattern, even as so much else washes away. In this thought, one finds a gentle assurance. Suppose the lab is silent and empty now, just instruments at rest, a bright dot on a power switch, a faint glow on a clock. The samples stay where they are. The slides nestle in boxes. The thin sections rest flat in their cabinets. Out in the world, landscapes are changing a little with each breeze. Somewhere, waves make their small sounds. Somewhere, a forest breathes. The same rhythms exist at the micro scale, inside the materials on these benches. Everything is slow and kind. A final tour through the microstructures feels like flipping through a beloved book without finishing any page, just reminding yourself of favorite images. The radial spokes of a sea urchin's spine in cross-section that create a snowflake made of stone. The skeletal mesh of a bryozoan colony, where calcified walls form hexagons that tessellate calmly. The granular structure of bone, with its medullary cavities, filled long ago with calcite spar that looks like shattered glass, frozen mid-shatter, but actually is smooth and cool to the touch. The suture lines of an ammonite shell, intricate without being busy, fractal harmonies caught at the edge of structures of the ancient world are tucked into stone. The instruments are off. The thin sections lie flat. The night is kind. Thank you for joining this slow walk through paleontology's patient, tiny mysteries. If this brought you a little peace, a small island of quiet in your evening, you can support more calm science by subscribing and leaving a gentle like, so we can keep releasing videos this often. If your eyes are heavy and your body feels comfortable, stay just as you are. Let the gentle